So as we get into day 2 here, all right, so we'll start with blue being a small. Where do you think our smallest side is, Blake? Up on top, right? This is 2 dots, so we're going to go, we're going to make our little square here, 2 by 2. So 2 dots by 2 dots is what? 4, right? So this small, the small side has a square with an area of 4, which means the side length should be what? 2, right? Because we take the square root of the area. So the side length is 2. Where's my medium side at? Sheridan, where's my medium side at? Right here? Yep. So this is my medium side. It goes down 1, 2, 3, 4, 5, 6. Okay? That means my other length to make the square, I gotta go 6 dots all the way around, right? 1, 2, 3, 4, 5, 6. And then I can connect the dots. So if I have a square here, the green one, the medium one, that's got a side length of 6, what's my area? Mind you, what's my area? If the side length is 6, right? How do we find the area of a square? Which is 36. So the area of the medium square is 36, which means my side length is 6, right? Square root of it. So that's the B side, 6. All right, so now let's take a look at our diagonal, which goes from here all the way down to there. So the slope, 1, 2, 3, 4, 5, down 6 and over 2. So we're going down 6 and over 2. Just leave the door wide open. Down 6 and over 2. So if my slope is negative 6 halves, and I got to make a square that has a negative reciprocal slope. What's my negative reciprocal slope of negative 6 halves? Andrew. Negative reciprocal slope of negative 6 over 2, 6. Positive, right? Awesome. Again, if I go 2, 6, meaning up 2 and over 6, I draw so I got to go backwards, right? Because I want my square to go this way. So I'm going to go down 2 and left 6. 1, 2, 3, 4, 5. So there it is. And of course, it's off again as usual. So there's my square, right? Not a perfect square, right? The blue and the green were perfect squares. This one isn't. So we have to box it in to find the area, right? That's a yes. Excuse me. I cough into my microphone here. All right. Big box. Oh, yeah, it goes up a row, so it's off. So, up here. 1, 2, 3, 4, 5, 6, 7, 8. This is an 8 by 8 square. What's the area? 64. Okay. And now these inside triangles, right? These are the guys we got to get rid of. All right, is 2 by 1, 2, 3, 4, 5, 6. 2 by 6. So half of 2 is times 6. 6, and there's 4 of them. So 6 times 4. So we're going to subtract 24 from 64 to give us 40. So if our area is 40 of this guy right here, the big square, what's the side length? What do we do the area to find the side length? We take the square root. So the side length is the square root of 40, because that's not a perfect square, right? Now let's think about this for a minute. Does the small side and the medium side add up to the long side area? It does. All right. And if you notice here, the relationship of the squares areas, we have two areas with perfect squares, right? The small and the medium. So we have two areas with perfect squares. But the one thing from the front side is consistent with them being right triangles. When you add the areas of the small sides, right, it equals the long side. The two that weren't right triangles in the front didn't do that, right? So let's see if this pattern stays consistent. Let's go down to the next one. Now again, it's hard to tell because that triangle's tilted, but let's work it out. All right? Would you agree the small side is right here? Yep, right? So let's do this one in red, just trying to keep our colors. All right, so my slope from here to here is up 1, 2, 3, and over 2. That means my slope is 3/2. All right, Joey, if my slope is 3/2, what's my negative reciprocal? Negative 2/3, good. So again, I'm gonna go backwards, so I'm gonna go up 1, 2, and over 3. So I'm kind of gonna be over here actually. We have to make a row of dots here. And again, because my board's off, it's gonna look a little goofy, but there. And then up 2 and over 3, so there's my other point. So there's my square, right? So let's box it in. So I have a square that is 1, 2, 3, 4, 5. It's a 5 by 5. So what's the area of a 5 by 5 square, Joe? 5 by 5 square. 20 what? 5 times 5. 25. So if the area is 25, and I look at these triangles, this is a 2 by 3. So what's half of 2? 1. And 1 times 3 is 3. So if each of these areas are 3 all the way around, and I got 4 of them, what area am I subtracting out? 4 triangles at 3 each. 12, right? So 25 minus 12 gives me 13. So notice that our side length is the square root of 13. All right? Well, let's do the medium square. I think the medium square is on top. Would you agree? I think the bottom one looks a little longer to me. Do you agree with me? Okay. All right, so let's go from here. This is the side we're looking at right now. So the slope here is down 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. So negative 4/6. So if my slope is negative 4/6, Brad, what's the negative reciprocal of negative 4/6? 6/4. So up 2, 3, 4, 5. Wow, this make me draw lots of extra dots. So 6 and 1, 2, 3, 4. So right, my shadow's in the way. I'm sure you guys have said that a few times. All right, so there are my dots to make my big old square here. So again, we want to find the area of that. We got to box it in, right? We went up 6 and right 4 on both dots, right? So let's box this guy in. This is going to start to get busy again. All right, so if my dot's going across, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, that's a big one. Is that right, or can I not count? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10, right? You get 10? What's a 10 by 10 square? 100. Okay. Just double checking myself. All right, so look at my triangles. 1, 2, 3, 4. So this is a 4 by 1, 2, 3, 4, 5, 6. So what's half of 4? 2, right? Times 6. 12. So if I got one triangle at 12, all four of them would total 48. So that gives me 52. All right. So last but not least, we'll go to blue. Our last side we got left standing, right? Which is really hard to see because we've drawn all over, but there it is. Right? So our long side is down 1, and then over 1, 2, 3, 4, 5, 6, 7, 8. So if my slope is negative 1/8, William, what's the negative reciprocal of 8 over 1? But again, we can't go up, so we're going to go backwards by going down and left. So 1, 2, 3, 4, 5, 6, 7, 8. Right there. And going to make us go another set of dots. Man. Need to give us more dots. All right, so there's our big square. So we're going to box this in again, like we have been. So this goes 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a 9 by 9 square. You with me? What's the area of a 9 by 9 square? Huh? 81. And if I subtract, these guys here are 1 by 7. 1 by 7. So what's half of 1? 0.5. And 0.5 times 7 is 3.5, right? 3.5. So let's take 3.5. 3.5 times 4. It's 14, right? So we're going to subtract 14 from this. And we get 67. And this adds up to 65. All right. So the sum of the area of the small and the area of the medium does not add up to, we're off by 2 here, right? So we don't have any perfect squares in this one, right? Because C would be square root of 67. So again, this has 0 perfect squares, kind of like what was the front side that had that issue? The third one, right? The obtuse triangle. All right, so last one. This bottom guy. All right. So obviously this looks like our side to start with, right? Tiny side. Down 2 and over 1 is our slope. So what would be the negative reciprocal, Sky, of negative 2 over 1? 1 over 2. So we're going to go up 1 and over 2. So there's a little square that we're going to box in. It's a 3 by 3 square. So if it's a 3 by 3 square, what's the area of a 3 by 3 square, Blake? 9. And then these little squares are 1 by 2, right? So what's half of 2 times 1? 1. So each area of the triangles are 1, and there's 4 of them. So that's a total area of 4. So we get an area of 5, which means our side length is the square root of 5. All right. So where's our medium side at? I think it's this one right here. Do you agree? All right, so let's draw a line just so. All right. So our slope is up 2 and over 1, 2, 3, 4. 2/4. What's the negative reciprocal of 2/4? Jasmine. 2/4, negative reciprocal. Negative 4 over 2, good. So we're going down 4, 2, 3, 4, and 2 over. Again, we're going to go the wrong way, right? So we're going to go up and left. 1, 2, 3, 4 over 2. right there. And 1, 2, 3, 4 over 2. So there's our square. So let's box this guy in. Oop, too far. So this square is a 1, 2, 3, 4, 5, 6. 6 by 6. So we have a 6 by 6 square. What's the area, Jacob? 36. And we're going to subtract out. This is a 2 by 1, 2, 3, 4. So what's half of 2? 1 times 4. And there's 4 triangles. 16. So we get 20 here. So B is the square root of 20. Alright, so just to help us, because you can't erase, but for me, digitally, I'm going to erase just so we can see the third side. Excuse me. Alright, so here's our third side right here. The one we haven't done yet, right? Now notice it's a straight line, right? How long is a straight line? 1, 2, 3, 4, 5. So if I go down 1, 2, 3, 4, 5, and we end up with a perfect square. What's the area if the side length is 5 by 5? 25. And the square root of 25 is 5. And again, does the areas of the small side and the medium side add up to the length? 5 plus 20, 25. Yeah, it does, doesn't it? So this is the right triangle. This is the right triangle. Your right angle is right here. Because this, and this are negative reciprocal slopes of each other. So to answer this little guy down below here, it says, what kind of triangles show the relationship of squares of the areas? Well, when we found the square, or the square, I should say the square root, right? The square of the small area, right? Square, right? Plus the square of the medium size, equal the square of the long side, right? Right? We took the area, which was length times width squared, right? So we took the area of this guy plus the area of this guy, and it equaled the area of this guy, right? So now we're going to fill in our little table in the back. Okay? This guy right here is going to turn into something magical in a minute. So let's flip it over. So it says, since you know the areas of the squares on the sides, you know the side lengths, use the table to find a symbolic way to represent the relationship between side lengths A, or side lengths in a right triangle. So if we go to fill in this table here, remember the acute triangle? That was on the front side of row 2, right? So the squares were 5, 8, and 9, right? And our side lengths were the square root of 5, the square root of 8, and 3, right? Right? We're not adding anything to this. We're just putting in all the work that we just did, right? In the obtuse triangle, right? That was the very one on the bottom of the first page, right? We had areas of the small side was 13. The big side, or the medium side, was 37. The big side was 68. And we got the square root of 13, the square root of 37, and the square root of 68 as the side lengths, because we took the square root of the area. So the first right triangle we did was the one on the top, right, of the first page. And that had an area of 9, 16, and 25, and the side lengths were 3, 4, 5. Now the one that they wrote in for us was the middle one, which we couldn't quite figure out. This is the data, that middle one on this page that we just came from. So we'll just leave that be. But we're going to notice a pattern here in just a minute. All right, the other right triangle was the one that we just did. It had areas of 5, 20, and 25, right? And its side lengths were square root of 5, square root of 20, and 5. So that leaves only the one last right triangle that we did. That was the very top one of the second page, right? Where it was 4, 36, and 40. And our square roots were 2, 6, and the square root of 40. All right, so here's my question to you. It says, is there a symbolic way to represent the pattern in a shaded portion of the table? So if you look at the non-shaded portion, right, what did we talk about earlier, right? Basically, when we figured out that these two sides did not add up to this side, right? Right? And what do you notice about the shaded area? Blake? Yeah, these all add up. The medium, it always adds up to the C side, right? The long side. So what could you say? Since this was the square sides, right? We could come up with the magical proof of a squared plus b squared equals c squared, which is the formula for the Pythagorean theorem. So you're like, wow, 2 days for that? Yeah. And we call that relationship, and that's how you spell it. Pythagorean theorem. I'll get out of the way so you can see it, so you can spell it. Yeah, it's long. And then again, we use this in a right triangle. So this is our right triangle. The smallest side is A. Okay. A is the shortest leg. The other side that makes up the right angle is the medium-sized leg. All right. Or because there's only 2 legs, this is the longest leg. And again, these two sides come together to form the hypotenuse, which is side C. Side C is the hypotenuse. The hypotenuse, you can always figure it out because it is opposite the right angle. It's right across from the right angle. And it's the diagonal of a right triangle. The hypotenuse is always the longest side, no matter what. Okay? So tomorrow, as we explored this for these 2 days, tomorrow we're going to get into how to use it. What does it mean? So, homework assignment for tonight. It's not 1 through 4. It's 1 and 4. So you might need some graph paper because you don't want to draw in the book unless you can draw it in the paper. I actually was able to draw it on my paper. But 1 and 4 is your homework tonight. On page 49.